Hi, I'm Mark with Mastercam, and in this video I'd like to show you a couple examples of how 3D tooling can be used to help make programming your parts easier. On this part, I'm using a dynamic lathe operation that is cutting out a channel. The tool for this operation was created from a DXF file that was downloaded from a tooling vendor's website. When I backplot the tool path, we can see the tool holder hits the part. Because the custom tool being used is only a 2D representation, Mastercam isn't aware of the curvature of the holder. What we can do to fix this issue is create a 3D tool. I can launch the tool designer by going into the Lathe Tool Manager and right-clicking in the part or library windows, or by opening the parameters for my tool path and right-clicking in the tool display window. Once the tool designer opens, I need to give the new tool a name, select the type of tool from the tool type dropdown, and set an offset number. On the insert page, I need to select the step file that I want to use for the shape of my insert. And I need to define the corner radius, which I can enter manually or select from the model. Using a 3D insert means that Mastercam can properly represent the relief angle of the cutter in backplot and simulation, which you can't do with traditional 2D lathe tools. On the holders page, I select the step file that defines the shape of my holder. I also need to define the machine connection plane, which is the rear face of this holder. Using a 3D holder means that Mastercam is now aware of the true shape of the holder, so false collisions like the one we looked at earlier are no longer an issue. Additionally, this means that collisions we may not have seen in backpart simulation due to an underdefined tool holder are no longer an issue either. For this example, I don't need to make any changes on the mating page, but if the tool and the holder were not aligned properly, this is where I could correct that. On the setup page, I need to define the cutting plane. In the machine orientation page, I can define the tool orientation, which turret it's loaded in, and the spindle direction. New in Mastercam 2020, the tool designer will automatically populate the compensation page based on the tool geometry and the machine orientation settings you defined. At this point, I can click the green check to finish creating my 3D tool and select it from my tool path. Once the tool path is regenerated, I can launch backplot and the tool is now properly represented, which means the false collision is no longer displayed. Another example where 3D tooling is helpful is with face grooving. In this example, I have a shaft with a face groove that is using a center for support. If I tried to program this tool path with a standard 2D tool, there is no way I would be able to get the precision I need or be able to accurately backplot or simulate this toolpath before posting it out. Thanks to 3D tooling, I can accurately represent a complex tool such as the one I'm using and get the results that I need.